Okay, well, welcome to all of our HMANA followers. We're thrilled to have you with us yet again for our monthly series of Lunch and Learns. Special thanks to Julie, as always, for helping to put these together and getting everything lined up. And we're excited to welcome David Brandes with us today, who's going to kind of just peek into some climate-related topics, especially with a focus on winds and potentially the change of winds that are happening at Hawkwatchers in Pennsylvania and maybe even beyond. So before we get too far along, just some words of note about Zoom. As a reminder, you can go ahead on the upper right-hand side of your screen. There's a little area where you can click view and you can customize your view to make the experience exactly how you want it. You will notice that you don't have the ability to share your video or your audio, and that is on purpose. So please pop open that chat. Already seeing people saying hello and letting us know where they're dialing in from. So we thank you for that. Please do so if you haven't done that already. But most importantly, with that chat, that is how we engage with you. And more importantly, it's how you ask questions of our speakers. So make sure that chat is popped open and ready. So as our speaker is going through his presentation, that if things come up that kind of have you scratching your head, feel free to ask those questions in the chat. So please do that. With that in mind, I'm going to go ahead and just share some things, current events and things that are happening in HMANA. We have a lot going on right now across all of our committees. And one of the more important things that we're ramping up for as a board is our yearly all-day meeting that we're planning in December. So we're looking forward to that, and all the committees are working hard to prepare for their goals and their strategies moving forward to bring more programs like this, more education, more research, all the things that we do to support not only our site coordinators and the migration sites, but you as our constituents as well. We have a lot to offer, and we want to continue doing that for you. Also, please go to our website, hmana.org, and check out a couple things for us. First of all, there's a couple tabs at the top for supporting HMANA and supporting Raptors, as well as ways that you can join us and become members with us. So please feel free to check those areas of the website out and be willing to join our membership or provide a donation if you have the means. It's tax deductible, and we're getting towards the end of the year, so it's a perfect time to make that donation. In addition to that, you'll notice on our homepage, there's a slider dedicated to our 50th anniversary celebration that we're ramping up for in just 1 year. So it's hard to believe we're already there, but November of next year in Duluth, we're partnering with our friends at Hawk Ridge, and we're excited to be able to share a lot of work that we're doing already, ramping up for what will be a really great celebration. So please check that out. There's ways that you can support, become engaged with us if you're interested in helping out. And then you can also sign up to hear more about when the speakers are chosen, when we have events planned, and all the happenings are starting to come together. So with that, I'll turn things over to Julie Brown, who will introduce Dav Brandes today. Go ahead, Julie.
Hey, great. Thanks for all that, Josh. I'm Julie Brown. I'm the Raptor Migration and Programs Director at HMANA. One other thing you can also put in the chat is your email address if you don't already receive our e-newsletter, which goes out about once or twice a month. Most of you looking at your names are probably already on that. So with that, I am very excited to welcome Dav Brandes today to be our speaker. I know if any of you have spent time at a Hawkwatch, any Hawkwatch, chances are the topic of weather has definitely come up. What the weather is, what the weather has been doing, what the weather will be doing. Like Hawkwatchers just really like to talk about the weather. And I know I've heard from a lot of Hawkwatchers, a lot of them who have been counting for decades and decades, just letting us know at HMANA that they're seeing recent changes in weather, and therefore seeing just different changes in raptor migration in their patterns. So this is definitely a hot topic, and we appreciate Dav coming to speak to us about it. David Brandes is the chair of the Integrative Engineering program at Lafayette College, where his areas of research are in hydrology, impacts of terrain on airflows, and movement ecology of raptors. He's a life member of HMANA serves on the steering committee of the Raptor Population Index project, and is also on the steering committee of the Eastern Golden Eagle Working Group, a partnership working to advance conservation of golden eagles in Eastern North America, which just came out with a great plan just days ago. He is an avid photographer, eagle watcher, and father of 2 teenage boys. So take it away, Dave.
All right, thanks much, Julie and Josh. Well, Julie, you teed me off well. I am here to talk about the issue of weather and how that's changing and how that might impact hawk watching and hawk counts. You also alluded to, teased something that I'll share at the very end about the conservation plan that we just came out with. And before we get started, I should point out that it's been a very exciting morning already for me. I had Sandy Lockerman at my house banding a adult female rufous hummingbird this morning. And that was quite a lot of fun and interesting. Okay, so title here is Winds of Change in Penn's Woods. And Penn's Woods, as many of you know, is a way of saying Pennsylvania. And so it is going to be Pennsylvania centric in terms of the data that I show, but I think as Josh alluded to, a lot of what I'm showing is regional, and not just in the fair state that I live in. The other thing I guess I'll say is that if you get lost in the data and the charts, you can always look at the pictures. The pictures hopefully will be rewarding as well. I don't know why I can't advance my slide right now. That's weird. Oh, there we go. I just clicked on the screen and it worked. All right, so the story starts where else but Hawk Mountain. So this is an image on the upper right of Maurice Brune. And so he did his first season of watching in the fall of 1934, about close to 90 years ago, and then wrote in the Auk, in his first paper about the migration, about the dependence of the counts, the numbers on weather conditions, and in particular, talking about a cold day immediately after rainy weather, strong winds from northerly quarters, preferably northwest, is most productive. And I think that has held up over time to a large extent, and many sites like Hawk Mountain, like Cape May, and many others, really those are the days that people really look forward to and enjoy because they are very productive in terms of numbers of birds and how close the birds are and all of that. So the picture then on the bottom right is what a weather map might look like for a day like that, where you've had a passage of a cold front and winds are coming out of the northwest, and you're anticipating a great flight and hoping you'll be able to stay warm for 8 or 10 hours. If we go back another 80 years or so before Maurice was at Hawk Mountain, folks like Thoreau, who was an amazing observer of nature and a great writer too, was noticing that, and I love this quote, it's a quote that I've used before, that hawk flight and the weather are closely tied. So the hawk is aerial brother of the wave which he sails over and surveys. So I love that quote. And this was somewhere around Concord, Mass. He could have been watching broadwings or red tails, or he's written about marsh hawks too, at least in those days, that's what they were called. So this is an observation that has stood the test of time, of course. And Josh alluded to this, we know quite well that the climate is changing. The graph that I have selected here this came out at the end of the summer, when it was announced that 2023 was the hottest summer ever measured. And that's what the red dots are. There was a thin black line put through those dots, but I put a dashed blue line because there's even a suggestion here of perhaps an acceleration of that summer heat. And so we know that our global system is changing. Less well known is what the impacts are on local weather or regional weather even. And in particular for us, how that might impact migration. It's not well documented or understood. So there's 2 questions here that I posed, and this work relates to conversations that we've had in the RPI group about data that we're looking at and trying to understand. So the first question is about I was interested in, well, let's look at the data. Have there been significant changes in surface wind speeds and wind directions as well during the fall months for the past 50 years? I'm in Pennsylvania, Hawk Mountain's in Pennsylvania, so I focused first there. It doesn't mean we won't expand the work at some point. The second question is much harder, and I'm not going to really answer it, but I'll maybe suggest a few things. And that is, can changes of weather and winds and so forth help to explain declines that we've been observing in raptor migration counts? Okay, so since this is an audience of hawk watchers, I'm going to throw out a little bit of terminology, and that is, when we're thinking about hawk counts and changes of weather, there's really two things that can change, and one is what we call availability, whether there are raptors to be counted, really, and detectability is sort of how easily we can spot them, how high they're flying, maybe something about the clarity of the atmosphere. But the important thing in terms of these terms is that if these weather changes favor, say, higher altitude flight, then certainly detectability will be reduced, likely, and counts could possibly decline, even if there are still birds flying overhead. They're just much harder to spot than, say, they used to be. The other thing is that if these changes in weather and really climate change actually what the raptors are doing and decisions they're making about migration and how far they're going, for example, then that's availability, and that might also affect what our counts trends maybe are doing. And I should have mentioned, I picked the red-tailed hawk for my cover picture because this is a classic case that's at least fairly well known through the work of friends of mine like Nick Bulgiano and Neil Peprocki and others have demonstrated that red tails indeed are changing their migration strategies. And there are plenty of red tails around. They just aren't going past Hawkwatchers nearly as frequently as they once did. And of course, both of these things could be happening at the same time. And that's what makes all of this complicated to unravel. But anyway, I just wanted to sort of highlight those terms because I think they're important in understanding the story. Okay, so I mentioned decline. So I'm going to show a little bit of data that we're looking at and when we're posing these questions. So I summed up all the raptors counted at Hawk Mountain since 1980 per year. So the first chart is all of them. And the second chart is I took out the broadwing numbers because I think broadwings are famously more variable than others. Some years are big years and other years not. And it's sort of hard to sort of tease trends out of that at times. So if you remove the broadwings, you see an even more clear trend. And I'll talk a little bit about the methods here later, but this is a very significant decline over time, starting sometime maybe around 1990 or so. And if you look at, these are just raw counts. So when we do RPI, we don't use the raw counts, but this is raw counts. And so the total number of migrating birds, not including broadwings, is like half of what it once was. And this is all, of course, post DDT. So, we had the rebound of many of these species after DDT, but this is a more recent trend in lots of species and not just at Hawk Mountain. And that's what I want to show next. Is that so these are plots from, if you haven't been to the RPI website, it's really great. We've upgraded it and there's really nice graphics and things there. So I'm going to show you a few examples. So of course I've mentioned that red tails, we understand that these are declines in migration counts, don't necessarily equate to declines in populations. So many counts are showing declines in red tails. A few are stable. The little blue round dots show that there isn't a significant trend, but most of them are distinctly downward and strongly downward. Here's the sharp shin hawk, pretty much the same story. There's one outlier in the west where that counts have actually increased. And by the way, this is data through 2019. We're currently updating with the most current data, and hopefully that's going to be done soon. The analysis will be hopefully in a few months. So we'll have the updated, but this is the 10 years ending in 2000 through 2019. So that's sharpshin. Here's osprey. Now, interestingly, if you look at the coastal sites for osprey, and Cape May in particular has an increasing trend, and the osprey numbers at Cape May are quite a bit larger than we're seeing on the ridges, the inland sites. But still, there's a very consistent downward trend across all these sites, except for a few outliers. And here's the northern harrier, same story, right? And again, this is one that even on the coast is declining significantly. So, and I'm, not even showing, American kestrel, for example. Those are the four I'm going to show. But I should point out, for all of these species, there's probably multiple factors at play. I mean, we know for harriers, loss of grassland habitat is probably part of the story. But so what I'm focusing on is not that stuff. West Nile is probably affecting some of these species. So there's a variety of possibilities, but really I'm just looking at weather. But it's interesting to see this consistent pattern across a whole suite of species, and it's concerning for sure. Okay, I do want to point out that this general story of changing winds and northwest winds might not affect all sites the same, right? So there are some sites, Allegheny Front is one that has a unique geography. This is in southwestern Pennsylvania. And actually, I grew up counting hawks on Allegheny Front down in Maryland. And so I've known for a long time that northwest winds aren't good winds there. So it could be that some sites are affected more than others. So if you're on Allegheny Front, you're hoping for actually southeast winds, the exact opposite. And so a weather map like the one on the right is what you'd be hoping for if you're looking for a big flight, say, of late October eagles at Allegheny Front. So there may be differences from site to site that we have to think about. Okay, so about the data and the method. So I focused on weather stations at airports. These are the ones that have the best quality control, the longest records going back. I was interested in back to 1970 if I could get it. In some cases, I couldn't. I used hourly data, and I used the months of September, October, and November. Of course, we know that there are migrating raptors outside of those months, but I focused on those. And then I looked at things like, are the mean velocities changing? And also, are there differences in, say, light winds versus moderate winds versus strong winds? And so I divided the data into these four categories that you see. I looked at winds from the four different quadrants plus the northwest, and then I divided them into these categories. I used less than 1 meter per second as essentially calm, and 1 to 3, 3 to 5, and greater than 5. And you probably wonder why I'm using the metric system. Well, eventually, if we want to publish this, it's going to have to be in the metric system. So I just figured I'd start there. Even though I don't think in the metric system any more than probably any of you, I like to think about 10 miles per hour, things like that. There, of course, is going to be missing data. That's always an issue, but there's not so much missing data when you're using a standardized source like this. So if there was missing data, I assumed it had the same distribution as the actual data. I used a certain type of trend test. I won't sort of belabor this, but it's a good test for looking at short time series that aren't necessarily normally distributed. At the bottom is an interesting point. It has been shown that if you have a weather station over many years and the land use in the area around it is changing, for example, warehouses or suburban development with lots of trees where once it was fields, that is potentially going to affect the wind over time at those stations. So that is definitely something that I had in the back of my head as I started this project. So anyway, I focused on these, well, 6 weather stations. It's sort of like a transect across Pennsylvania. And I'll show a map of that in a second. So really what we're talking about is a thing called a windrose. And I imagine many of you maybe haven't heard of that terminology. It's a way of plotting wind data where you're basically looking at the frequency that wind blows from particular directions and particular speeds. So this particular, quote, windrose, I guess if they're sort of symmetric, they might look a bit like a rose, but they're not red, only small parts of them are red. They're more like a rainbow rose, I guess. So this particular site is showing that there are frequent winds from this sort of west-southwest quadrant, and a lot of high winds. So the darker colors are the higher winds, right? So this is a highly biased wind distribution. It's a site in the northern plains. It's actually in Alberta, where the wind basically blows from the west-southwest pretty much all the time at fairly high wind speed, right? So, and this is a good place actually to see golden eagles on migration. So that's just the first example. So here I'm going to show these quote wind roses for my sites that span Pennsylvania, and you can see that there are definite differences. Although we all think of sort of prevailing winds coming from the west and northwest in this part of the world, and not just Pennsylvania, but in the Northeast. But there definitely are differences from site to site. And some of this is differences in local terrain, right? So there definitely is a preponderance of either west or southwest or northwest wind, but it definitely differs. And certainly the components from other directions differ more from site to site. So that's something to keep in mind, that the baseline is not the same for all of these different places. So I'm basically focusing, and these actually are plots for the month of October. I'm going to focus on changes in these wind roses over time, basically, but simplified so that there's only 4 quadrants and 4 different wind types, wind speeds. All right, hopefully I'm making sense, because I'm going to keep plowing ahead. And eventually I'll show you some pretty pictures if you're getting lost. Okay, so first I'm going to show you, I first did Allentown. Allentown's the closest airport and long-term station to Hawk Mountain, so it made sense to start there. And I always wanted to look first at, is there a significant trend in fall temperatures? And you'll see in this case, even your eye can kind of pick it up. This is a highly significant increase in temperature so each data point is the mean temperature for those 3 months for a particular year. So there's a definite increase in temperature. The mean wind speed is my next plot. So you see that there is a significant decrease in mean wind speed in Allentown. Okay, so means are interesting, but I'm more interested in these components. So I'm going to show you some plots of different wind components. So the top one here is same Allentown Airport, preponderance or occurrence of northwest winds greater than 5 meters per second. Okay. So we see a decrease, right? And it's highly significant. If we look at northwest winds in the next sort of speed categorization, they're increasing. There's sort of a trade-off. If you lose winds that are high, they got to go somewhere. And so we get more of these moderate wind speeds in Allentown. So decrease in the highest, a little bit of an increase in the moderate ones. And then we look at west winds, pretty much the same story. The strongest winds are decreasing. The moderate winds have increased a little bit, but they have trended sort of flat lately. And then if we look at the winds that are less than 1 meter per second from any direction, there's a significant increase of those over the long term. So there is short-term fluctuation. So if you just look at the last 5 years, it looks like that component has decreased, right? So anytime you look at weather data, meteorology, hydrology, there's always lots of variance and variability, probably even more so than hawk migration counts. So we do sort of have to look at these long-term trends. Okay, so some pretty pictures there for you. Sharpshin, a diving peregrine, and a bald eagle below eye level, which we always appreciate. All right, so now I looked at this data. I thought, wow, this is pretty significant. Things are definitely changing. So I said, let me look at another weather station, because maybe Allentown is one of those. Certainly there's been a lot of warehousing and suburbanization around Allentown, where the airport is located. It's not in downtown Allentown. So I was wondering, well, maybe this is just a result of that effect of building around the site. Well, so I looked at Reading next, which is the closest one to Allentown, and it has essentially very similar patterns: increasing temperature, slight decrease in mean wind speed, decrease in highly significant decrease in the highest winds, a bit of an increase in the moderate winds. I have a bit of a problem because the bar at the top is covering things. Okay, so west winds greater than 5, those are decreasing over time, increasing moderate winds, and whoops. Now we're looking at what? This darn bar. Oh, south winds have increased quite a bit at Reading, and east winds at the lowest category of wind, right? So more of those off winds at low wind speeds in the Reading area. And, well, yeah. Okay, more pictures, okay? So just to pause and let you think about that. So essentially a similar pattern at Reading as at Allentown, although definitely more of a shift to these light winds from the off wind directions. And here we have some pretty pictures of turkey vulture, juvenile goshawk, a kestrel, an adult golden, and a red tail. And so some of these are some of the ones we're very concerned about, others not so much. Turkey vultures, not so much, but we do need vultures around, don't we? Okay, so this is a big table of all of those. I don't like showing tables because you get lost really easy. The point of this is I'm showing everything on one slide. So I've got all 6 weather stations left to right. That's west to east. In the one case at University Park, Pennsylvania, which is where Penn State is, where you would think they have the best data of all, there wasn't any wind data collected, or at least not available until 1984. But you see a general pattern here of decreases in the red stuff is significant decreases. The green stuff is significant increases. So there's a general pattern across many sites of a significant decline in the strongest components of wind from any direction, but certainly from the northwest and the west, with the exception of University Park, Pennsylvania, which is the one that's missing some of the early years. I'm not sure if that's an artifact of looking at a different set of years for University Park. And we see a lot of increases, and it's not the same at every site, and I wouldn't really expect it to be, but lots of increases in the moderate to low wind category. And way at the very bottom is the calm wind, so less than 1 meter per second from any direction. If they're changing, there's more of that, right? So at Pittsburgh, University Park, and Allentown all show a significant increasing trend in those wind conditions. So the general pattern is more light winds, less strong winds, right? And that's pretty consistent across many sites. And so that's gave me confidence that what I'm seeing is a real effect of atmospheric changes and not necessarily just changes in land cover around these sites. And I haven't gone to this step, and I could, of looking at aerial photos and demonstrating with GIS or something that there is more buildings and forests around some of these sites. That would be another follow-up step that could certainly be done. And then I was happy to find that I wasn't crazy. There has been some work done on this, but this is a little bit dated. 2009, there was a comprehensive study, wind speed trends over the contiguous United States. And so this is not just Pennsylvania, right? So the quote from the paper is 2 observational data sets, both exhibit an overwhelming dominance of trends towards declining values of the 50th and 90th percentile and mean wind speed. So 50th percentile means the median, 90th would be a higher wind speed. So a lot of declines continentally. And this, looking at the data from their paper, was particularly true in the eastern US, the northeast US. So that's the results that I found just for Pennsylvania, for our region, seem to be held up by, what's happening in other places. So there is a tendency toward a general slowing of the atmospheric circulation, which Hawkwatchers have kind of noticed, I think. All right, so one other thing I want to show, and that is, you may have noticed this just with your eye, but we did a different kind of a test called a change point analysis. So that's not a trend test. It's a, where do we find the sharpest shift or change in the data? And many of those occurred in the 90s and early 2000s. So it's a little bit hard to say, is this a downward trend or is this a shift? Because some of them look more like a shift, right? Where sort of in a space of a few years, things just shift to a different mode of operation. So there's a hint of this, I think, in each of these plots, and certainly in others where it looks like in the area that I banded in blue, there was a lot of change over that period. And then maybe since then, things have sort of stabilized at this new reality that we are experiencing as Hawkwatchers. Okay. I think I'm getting close to wrapping this up with like, what's the take home here? So I have some conclusions here. And so you're not imagining it. Fall weather, when you're sitting up on your Hawkwatch, has changed. It's getting hotter. Wind speeds are decreasing, in particular, the strong winds. And I should have mentioned, 5 meters per second is about 11 miles per hour. So I gave all those in meters per second, but those stronger winds are definitely less frequent. And certainly if we're thinking about cold fronts and strong winds and the kind of days when I might decide to drive 2.5 hours to get to Cape May, that's less frequent now than it used to be. So a lot more of the light winds and sort of calm conditions. And interestingly, at least for me, is that pattern is relatively consistent across a number of different sites and also consistent with other research. And so I don't think that these results are unique to Pennsylvania. I should have mentioned the reason I focused also on Pennsylvania is I went as one-stop shopping. I could go to the Pennsylvania state climatologist and all the data is formatted exactly the same. And so you can download it and use it and not have to fiddle around with different formats that other folks are using. And so I started with that. But again, I don't think these results are unique, certainly not to Pennsylvania. Okay, so now I'm going to sort of extrapolate a little bit and say that these shifts in weather that we're observing would favor more use of thermals and more of a broad front migration and less concentration in the places where we like to go and do hawk counts because we're going to see stuff, right? So that means that it's getting harder to see raptor migration under those kinds of conditions. So the counts could certainly be going down because of a shift in detectability, a shift in the kinds of flight that the birds are using during migration. I hope this isn't the end of the story. This work came out of conversations in RPI, and particularly Laurie Goodrich's concerns about the data trends at Hawk Mountain. I think they are more widespread, so I think there's more work to be done on that. And some of you may have wondered, are we taking this into account when we're doing our trend analyses every 3 years in RPI? And we're actually not, but it was looked at in the book that was produced back in 2008, The State of North America's Birds of Prey. If you look at the chapter on RPI in practice, it is something we had in a model, decided it didn't provide any improvement in prediction or in fitting of trends. But I think it might be time to reevaluate that, to look at that again. Are there ways to adjust our model for the effect of wind and weather? The difficulty in part will be that different sites respond differently to these changes. I mentioned in particular Allegheny Front. In our state, Wagoner's Gap is another site that gets a lot of birds, and they do quite well on south winds, and much better than, say, Hawk Mountain does on south winds. And so I think we'd have to have models that are unique to each site, probably. The Northwest thing, I think, works at many sites, but not all sites. And that's kind of it. I want to say thanks to some people here in particular, Julie Brown for all her work for HMANA and inviting me to do the talk. A lot of these results I passed over to George Young. He's a professor emeritus at Penn State. he's a guy who knows a lot more about meteorology than I ever will, and he's also knows a lot about birds and bird flight. So it's good to have another set of eyes to look at the results. Certainly Laurie Goodrich in helping kind of the impetus for looking at this, and all my RPI colleagues and team. If you haven't been to the RPI website, you really should check it out. It's pretty awesome. Julie teased the fact that on Monday, our Eastern Golden Eagle Working Group released a plan that we've been working on for about 3 years, a conservation plan for the eastern population of golden eagle. So you all can go to our website and download that. It's a, if I may say so myself, a pretty impressive piece of work with a lot of really nice pictures in there of golden eagles. And I put my favorite golden eagle shot on this last slide. And if you go to the RPI site, you'll see it there too. But that's all I have. Happy to take questions. And I'm going to put up one more slide just to remind people that there's a lot of work that goes into these programs. And I guess it looks like we're going to take a month off for the holiday. And yeah, I'm done. Thanks. Hope you all enjoyed it.
Thank you so much. Thanks, David. You should go back one slide while we answer questions. I'd much rather look at your amazing photo of a golden at eye level there. Yeah, that's what I dream about seeing at our Hawkwatch every fall. But thank you. That was great. Really, how you can put things into perspective. I feel like you really did a great job in making your graphs and tables understandable there, which is not always easy. And we do have some questions, so I can jump in. We had a plug for the metric system from our friends to the north. And Yvonne is wondering, would the wind data be paralleled by atmospheric pressure? And also, is humidity changing as well?
So I didn't look at humidity much. I did look at pressure. And originally I thought, and I talked a little bit to George Young about this, that it would be nice to have a metric for, say, cold front passage. So that might include, like, for example, a rise in pressure, a shift in wind direction, an increase in wind speed. So I played around with that a while, and it's just not an easy thing to tease out of the data. And there really isn't a sort of a standard definition of what is a strong cold front versus a weak cold front. So for now, I left that out. I think that's something we could do more with. But the point about humidity is a good one. So originally, I thought I would basically drop out any days where, let's say, there was more than a trace of rainfall, or maybe the relative humidity average was above like 95% or something like that. Trouble is, the precipitation data is very gappy. There's a lot of missing data. And so I decided I was just going to ignore that. Certainly there are days when it's raining and maybe the wind's calm, right, that are showing up in the analysis, and we already know the birds aren't going to fly that day. So that is a bit of a weakness. We didn't control for humidity effects or whether or not it was raining on a particular day. Good question.
Thanks. Marianne is wondering, so what does that mean in relation to availability and detectability?
Okay, so in terms of detectability, I think we can definitely conclude that detectability has gone down. If there are fewer days with higher winds, then the birds tend to fly higher. They tend to use more thermal lift rather than ridge lift, or graphic lift, we call it. And so the birds are flying higher. They're just harder to pick up, particularly if it's a blue sky day and the winds are calm. I think that our effectiveness as observers is just not as good. So they may still be the same number of birds flying overhead. It's just much harder to see them. Availability, I don't think necessarily we can make much of a conclusion about. So it could be that connected with these changes, I don't have the data for this, but connected with these changes, the birds' urge to migrate has changed as well. So if the weather is warmer and if there's not these cold winds from the north, they may just stay home. But most, a lot of that depends on whether there's available prey, of course. And so I can sort of imagine or theorize that it's changed the availability, but that's a tough one to look at with just weather data. I think the better way to get at that is to combining these data sets is always the interesting thing. And so looking at what's happening with trends of birds in wintering densities and ranges with migration counts with weather, I think that's where we can get at this availability question more accurately. And certainly with red-tailed hawks, that's been very helpful. And so actually RPI is now routinely looking at CBC data as part of our decision about whether to put a bird on the raptors at risk list or so for example, if we just looked at the hawk migration data, you would be tempted to put the red-tailed hawk on the raptors at risk list, but we didn't because there's good data to suggest that they're just shifting their migration strategy and their wintering range. But yeah, good question. And I don't have a great answer.
Yeah, that's one of the cool things that we did with the upgrade on the new RPI website is as Dave said, combine our migration data, all of your migration data with CBC data. So you can go on and see these great trend maps now where they overlay RPI data with trends from Christmas bird count, and it gives you a better sense of what we're learning from wintering populations as well. The next question is there any change in time of day, max or min wind speeds?
Have not looked at that. Not sure.
Okay. And then we have another question. Is there any relationship whatsoever of change in migration paths with the change of the location of magnetic north?
That's out of my realm. I'm sorry.
Okay.
I think for potentially for some of the long distance migrants, I don't think for some of many of the species that I showed those maps of declines, osprey would be a definite exception, are what we call short distance or partial migrants. And so I don't think, I'm not an expert in all aspects of this stuff, but I don't think that magnetic thing maybe is a huge aspect of their orienting during migration, but certainly is more of a case for, songbirds that are migrating thousands of kilometers over the ocean and things like that.
Okay, great. And then I think just lastly, I was wondering if you could comment, if you could just speak to the importance of collecting data at Hawkwatch sites that may not be seeing big, amounts of raptors like the old days. Could you speak to that and the importance of continuing monitoring? I know I've heard from many sites that are frustrated. They can't get those big broadwing days like they used to, or they, it's not as exciting for them. They can't draw the crowds and speak. Maybe we could get your perspective from an RPI or long-term monitoring perspective.
Yeah, I mean, I totally get that. I mean, if you look every day at the count at Wagner's Gap, you're going to go home crying half the time, right? If you don't count at Wagner's Gap, or at Corpus Christi or someplace like that. But in terms of what we're doing, there's a couple things. One is what we're seeing is that the regional patterns differ significantly, not just west to east. Northeast versus central and so forth. So having sites, first of all, that are filling some of those gaps in space is very important. And again, they're not all of them aren't easy places to watch hawks. I mean, not every place has these long linear ridges like we do in the Appalachians, in the central Appalachians, or coastlines where there's a peninsula, And so there's always a tendency to go where we know we're going to see a lot of hawks, and for some reason, I've always been kind of cantankerous about that. I've always been somebody who wanted to go try another place because I was curious about what's happening, at some other place or site. The other thing is spring count sites. We don't have that many, and we really need them because there's so much that we don't understand about spring hawk watching. And again, in the spring, when majority of the birds are migrating in April, the thermals are much stronger than they are in the fall, and a lot of birds are really high, and it's really hard on your eyes, and you get to be older and you can't see them anymore. I know that's frustrating. But in terms of having a network that we can rely on, that we can understand these changes sort of regionally and over different seasons, it is critical. It may be less critical to have, 3 sites lined up along the same flyway within 50 miles of each other. But I know there are sites that are sort of feel like you're way out in the middle of nowhere and nobody's paying attention. If I didn't have to have a day job, I'd come visit all of you like Julie does, because it's important work that you're doing. I know a lot of sites, you're looking around, where are the young people? Who's going to count 20 years from now? And it's a tough thing. Anyway, I hope I've said what you hoped I would say, Julie. Those sites are critically important. And I think about the Central Flyway. We just don't have much data, and it's pretty damn flat out there. And it's hard to find places where, you think there might be concentrations of birds. But certainly I applaud anybody who is like the Steve Hoffman of new go find Hawkwatchers, where people never dreamed that there were. When I went up to Tussey Mountain, it was good luck in part, but I was looking. I was thinking, geez, these eagles have to be flying somewhere. And I looked at maps, and then it just so happened that spring break at Penn State was in the middle of March, which happens to be, I didn't know this, the peak of their migration. And I took a walk with my dog down the ridge, and right over my head were these adult golden eagles going past. And so I was hooked. So get out there, look around, don't be discouraged.
All right, great. Yes, and we are eternally grateful to all of you that are out there doing what you do. We really appreciate it. A few more questions if you have time, Dave. It's almost 10 of now. Okay. Andrew's wondering, in the slide with the blue highlight bars, what years did those bars cover? It didn't seem to be visible.
Oh, is it off the bottom of your screen? I'm sorry about that. I can see it here for some reason. So it starts at 1990 and it goes to right around 2005. And so that was based on this other type of analysis we did, where we're looking for these change points, and a lot of them grouped in that area. So I did that for all the different time series for all the different stations. And I don't, off the top of my head, have a great, explanation for why that particular time period, rather than just like a general decline. The atmosphere is very nonlinear, so it tends to do things in nonlinear ways. So I suppose we might expect weird stuff like that.
Okay. Nick has a question. He's saying, which raptor species do you think are most affected by wind changes?
That's a good one. I think, for example, in terms of counting, if sharp shins are low, you can count them. If they're high and it's blue, it's really hard to count them, right? So I would think that sharp shin is one, that if it starts using more of these, thermals and broad front migration, the counts are really going to drop. But of course, there's other things going on with sharp shins too. I don't know if I should reemphasize that, is that in all of these cases, there's probably multiple pressures. I don't know if I want to use death by 1,000 cuts, but there are multiple mechanisms going on probably in all of those declines. And it's maybe not just changes in weather. But sharp shin I would put on the list for sure. Any of the bootios are really good at soaring. They don't need ridge lift. They can go. We learned this, I'm pretty familiar with golden eagle migration telemetry data. And you always think of golden eagles, following the ridge. They only do that when it makes the most sense for them. They're often very high, crossing over ridges and valleys in places that, you think of a golden eagle as a pretty heavy bird that's not going to be way up there. So imagine what that's like for a red-tailed hawk or a broadwing or a sharpshin.
Okay. Suzanne is commenting, any number, including 0, is enlightening data. I agree, Suzanne, for sure. No hawks is still very important data. We need to remember that. Sharon, this is our last question, I think. Sharon is saying, can thermal imaging help locate the migrating hawks?
Yeah, that's a good idea. So I'll say one other thing. So I visited a site, a wind energy site in Wyoming, where they're using these cameras to detect eagles flying over and then try to identify them. They're amazing at detecting flying objects. Every time we saw that camera turn and look up, we would stare way up and then we'd see a bird. They're not very good at telling you what kind of bird it is, but if you had a detection device at your hawk count that basically just alerted you when something was going over, I think that would improve detectability a whole lot. So it could be thermal imaging, it could be visual, it could be radar or something. Somebody techie should invent us one of those.
Yeah, maybe we'll get there someday in the future. I think that was the last question. So you can forward to the very last slide if you want, Dave.
Sorry. Yeah.
Oh, do check out that Golden Eagle Conservation Plan. I highly recommend that. And congratulations again, Dave, for your efforts on that. And thanks so much for speaking to us today. I really enjoyed it. Josh, do you have any last minute questions or comments?
I do. Thank you, Julie, and especially thank you, Dave. It was a great presentation, and thank you to all of you who joined, especially those who were brave enough to ask your questions. Some really great engagement today, so thank you for that. And Dave, I think your last comment about somebody techie, it has me thinking, if the detection devices are that good, if we could match that with something like Merlin and attach a video camera live that would talk with the AI that's built into Merlin, potentially both of those things working together could maybe detect and identify the birds. I hate to say it because I don't want to walk ourselves out of jobs, but we could still be there to enjoy it. We'll see what happens. At any rate, thanks everybody for joining. Again, like we said at the beginning, please go visit HMANA.org, especially the support pages, and become a member. Join our kettle, support us, support programs like this. Your donations are huge. I love what Dave mentioned about the importance of visiting sites where all of you are, and that is one of the key things that we want to see more of, especially with Julie Brown moving forward. And so this is what these donations do for us. So it helps us support you, especially if you find yourself as a volunteer or a site coordinator at one of our many sites around North America. So thank you, everybody, and I wish you all a good rest of your week. Just a reminder, for next month, we will be taking a break. We always take December off. And so we will look to seeing you again in January. Happy holidays, everybody, and we'll see you in a couple months. Take care.